Hello, grade nines, and welcome back. Oh, yeah, yeah. So yeah, let's carry on here and with our activity 3. Good idea, hey. So we got this relationship given to us, and this looks similar to yesterday's activity. And that is we're given. We're given a relationship x plus 2y equals 4. We need to complete some sets of coordinates and then plot them on our Cartesian plane. Now, there are 2 to do, so I don't want to do too much of this one. But let's pick out, say, this one here. Let's do that one and maybe... Oh, fraction's a good one, right? So those 3 we'll do together. And then after that, leave you to do it. How does that sound? Right. Sounds amazing, I'm sure. So, 0. So remember, we've got this equation, and we're just checking, we want to make sure it's true. So if x is 0, 0 plus 2y equals 4. Don't worry about solving equations and subtracting and dividing from each side. Just think 0 plus something gives us 4. So this something here, and the something I mean is the 2y. That bit must be 4. So in other words, 2 times y must be 4. So what's the value of y? Well, I think the value must be 2 because 2 times 2 is 4. And for now, we're just keeping that as a concept, not, okay, so do this, divide by 2, divide by 2. Just kind of if you can see it and work towards that, that would be great. Okay, so we got 0, 2. Maybe let's do this 6 over here. So for this one, we're going to say, I'm scribbling around here somewhere to go, well, 6 plus 2y equals 4. Okay. So again, let's just think of this conceptually and not worry too much about solving equations. We're going to get to that. But to go, okay, so 6 plus this something. Let's put some mustard around this tomato sauce and say, so 6 plus something is 4. So this something over here, well, it must be negative 2. So 2y should be negative 2 because 6 minus 2 equals 4. And 2 times what is giving us negative 2? Well, it's negative 1. So that looks like it should be negative 1 over there. Okay, and no issues if you're going, oh, well, actually, I'm feeling a bit more comfortable to go, well, from here I would like to go. So let's just look how to solve this as an equation. Because when I picked up from the speedies and auto hires and yada yadas and that, you're kind of getting keen to solve these equations. I liked it. And there's this lovely idea of, okay, subtract 6 from each side, subtract 6 from each side. So good I had to say it twice. So you got negative 2, and then you got, okay, cool, there's 2y, so divide by 2, and therefore y equals negative 1. Which is what we said here, but I just don't want to get too bogged down by solving equations. Look, there are lots of points. It's not about an equation for each. Okay, before we do this third point together and then plot it, I'm just going to throw in a pause and breathe. Cool. I know I'm feeling a bit better now. So we've got our third point I said was this one over here. So we've got negative 1.5. Let's find we can scribbles in here, I think. So we got x plus equals 4. Now 2 times negative 1.5 is negative 3. So again, without going, oh, solve the equation, just we are solving the equation, but going, so what do we need to add to negative 3 to get to 4? Hey, maybe you're doing this in the classroom and you're looking at the front of the class and going, well, there's that beautiful number line over there. 1, 2, 3, 4. And we're at negative 3, so we've got negative 3. So we're going, okay, cool, well, what do we need to add to negative 3 so we can get all the way up to 4? So what do we need to add? Well, I think we need to add 7. Let's just check out this. Is 7 plus negative 3 4? Yeah. What's another way of looking at this equation? Yeah. x plus negative 3 equals 4. What's another way of looking at that and therefore determining what x is? Okay, I'm hoping there are going to be a range of responses coming. The one that I was seeing, and I'd like purposely say range of responses because no one particular way, but kind of one way I think about it is to go, well, if we're adding negative 3, that's the same as subtracting. So this is the same mathematically as x minus 3 equals 4. Because if we're adding a negative, then we're subtracting. So we can just ask ourselves, what do we need to subtract 3 from to get to 4? So then in number line terms, that looks a bit different because we want to get to 4, and this time we know that we're subtracting 3, and we're asking ourselves, so where must we have started? Well, 7 minus 3 gives us 4. Gets us the same answer in two slightly different ways, which is kind of cool. Like, I hope you get this, that it's quite cool mathematically how often there are so many different ways to look at solving a problem. And they don't always give you the same answer or solution, funnily enough. So, yeah, don't think, oh, well, that's the right answer, and many ways it doesn't matter. No, it's fascinating that different routes may give you different solutions and make you think in different ways. One last pause, breathe before we plot those 3 points, and you can do the rest. Okay, so, whoa. There's my pause, breathe. So this point here, 0, 2. 0, 2. I'm going to ask not a trick question, because I'm kind of asking this. This 0, 2 doesn't lie in a quadrant. Why does it not lie in a quadrant, and where does the point that we're going to plot is 0, 2. Why do I say it doesn't lie in a quadrant, and where does it lie? Well, it's lying right here on the y-axis, because for the x-axis, we've gone, in fact, I can be like in the middle and go, so there's the positive side of the x-axis, there's the negative side, but it's 0, so we haven't gone anywhere, so we're straight up above. And then for the y value, well, we've gone up 1, 2, and that's where our point is. Okay, cool. So that was that point, and 6 minus 1, you're plotting points, and then quite happily before, judging from what I saw from the lessons earlier in the week. So that second point, I'm just going to scribble it here because I'm so zoomed in. 6 minus 1, minus 1 is, well, we start with our x point. So let's see if, I don't know if I can get there. But we must go along by 6, and we must go down by minus 1. So we must be over there because we've gone across by 6 and down by 1. So our second point must be over there. I don't know. Hopefully that sort of matches up. And then point 7, and we haven't done fractions plotting, but for our point 7 minus 1.5, well, we've gone across, so I'm way in the way here, but, this way. So we've gone across to 7, and we've gone down now by, let's move me so that I can, this is when I try and be too fancy, right? So let's move me here. Oh, there we go. So we've gone across by 7, and we've gone down not by 1, not by 2, but by 1.5, so it's like there in the middle. Let's see if I can hold that and hit my finger here. Look at that. That was quite cool. Come on. Okay, anyway, that's the idea. That's plotting of the points. I'm whizzing around the bottom of the screen here just for fun. You're going to plot these points, and you're going to notice something. Maybe, do you think you'd know what you're going to notice already? Like, do you have an idea of what you might notice? Okay, and I mean, it's like maybe sort of forming there. So finish off that one. Head off to question B after that. Finish off that one. What do you notice about those points? And then things are gonna get even more interesting, right? Okay, cool. Well, enjoy that. And I just like this idea of What's no, no good. Okay, okay, okay. Goodbye.